Example 4. Consider the functions f y equals 5 to the power of x and g y equals square root of x. In part A, find f of 2. So let me write down the function f y equals 5 to the power of x. Now, if I want to find f of 2, I have to substitute 2 for x. So f of 2 must be equal to 5 to the power of 2. And hence it is 25. 5 to the power of 2 is 25. So f of 2 is just 25. This is part A. In part B, we are asked to find g inverse of 4. Okay, so this is what we want. The fact or the trouble here is that we do not have the function formula for the inverse of g. We have to find it first. Okay, so let us start with g itself. So the function g has the formula y equals square root of x, and of course this function is defined for x which are greater than or equal than 0. Okay, so the domain of g is just the set of numbers starting at 0 and going to infinity like this. And of course, if you look at the values of this function, you see that the range of this function g is represented by the same interval from 0 to infinity, because the square root values are only positive or 0 when x is 0. So this is the function g. Now, if we want to find the formula for the inverse of g, what we have to do actually is to replace x and y variables by themselves. So I do the replacement. I exchange y for x. So what I get is x equals square root of y. And now I need to express y. So therefore I take the square of both sides and I get x squared equals y, and hence I can see that the function g inverse is going to have the formula y equals x squared. Now what we have to take into account is the fact that the domain of the inverse function should be the same as the range of the original function, and hence I have to write something like this: x is greater than or equal to 0. So this is the inverse function for the function g given here by this formula. Okay, so you see this is not an ordinary quadratic function. It's the quadratic function with the restricted domain. Now let us try to do what we are asked to do in this exercise. In part B, we are asked to find the function value of the inverse function at 4, so g inverse of 4. To do that, we take the formula for the inverse function and replace x by 4. So what we get is 4 squared, and you see 4 squared is 4 times 4, it's 16. And hence this is the answer for this part B. Now in part C, we are asked to solve the equation g inverse combined with f, like this, of x equals 25. So let me first replace this form of notation with a more convenient one. So it means we have to take the inverse function of the function f of x, and this should be equal to 25. Okay, so function f goes first, and then so this is the first function that we combine, and then comes this second one. So we read it from the right to the left. This combination, this process of composing functions starts from the right and moves on to the left, like that. Okay, so this is what we have to solve. We know the equation of f of x. I will just copy it here. So f of x is given by the formula 5 to the power of x, and g inverse of x is given by a formula x squared, like that. Okay, so if we want to assign any meaning to this, we should replace this expression on the left-hand side of the equation by something we can understand. So we have to evaluate g to the inverse function of g of, and instead of f of x, I just write 5 to the power of x. So this is to be equal to 25. Now, if I want to evaluate g inverse of 5 to the power of x, I use this formula here for the g inverse, and instead of x, I write 5 to the power of x. So this is its first variable, its x variable. So therefore, what I get is x squared, but my x is 5 to the power of x. So this should be squared, and this should be equal to 25. Okay? So this is the equation to solve. Now, if we understand what 5 to the power of x to the power of 2 means, we can do it easily. So this actually means 5 to the power of x times 5 to the power of x, and this has to be equal to 25. Hence, what you get here is the product of two powers with the same base, so it should be 5 to the power of 2x equals 25. And hence, if you replace 25 by 5 to the power of 2, which it really is, this is 5 to the power of 2, you get 5 to the power of 2x equals 5 to the power of 2. And therefore, you can say that 2x and 2 are the same. So you can write 2x equals 2. And therefore, x must be equal to 1. And this should be the solution of the equation given in this very strange and difficult form. So this is the answer to part C.